Okay, good afternoon. It's morning. I'm thinking afternoon. Boy, it's been a long morning, obviously. Friday, at least I've got the day right. We're at the end of the week, week 1, and spring 2003. I've returned, or at least have graded the papers, and they are in the process of circulating around. Much improved. Some of you are still a little bit less than what I'd like, and again, the rule of thumb. Look at the paper, and if you can understand what a problem involved, then you have it done well. If you can't figure out what you did just one day later, then it's certainly not an adequate presentation, but very good improvement, very pleased with that. What I'd like to do at this point, I finally got some more equipment to function the way I'd like, and we're going to go to the document cam for a moment because I did want to let you see what the web page looks like for the URL that we've talked about. And as we look at the bottom right-hand corner, you have the Math 10, and if you look at the upper left-hand corner, we have the Math 134, and in the center, and that's supposed to be a globe, but you can clearly see it's been elongated. If we come back to the zoom, it looks like the globe. We get an egg out of it now. But you'll notice the little area that's defined there where I have the cursor, and if I click there, what we pick up is the Math 70 homepage. It's supposed to do and didn't. Let's try one more time. There we go. And that is the page that gives you the content for what is being done in this course, and in particular the evening broadcast. If you wanted to re-watch it, if you have a computer with broadband, you find the simulcast link. It's the second one from the top. And I don't have the appropriate media player. I'm going to try that in a moment. But rather than be a risk taker at the moment, I'm going to come back while I can still look at what I want here. And that is, as we scroll down the page now, there is an area called Spring 2003 Schedule, and that's what I wanted to look at. So if I come down to that and simply click, this is going to give you the schedule we talked about. It's what I've asked you to go ahead and print. And as I zoom in there and then come down a little bit further in the page, let's see, I went too far. Let me go there and let me just scroll down now. And we are, of course, in week 1. I went a little bit too far. Week 1, and then, of course, we have the second week. But anytime you come into this, if you just click on the week, you get the current week at a glance. I'll have it set up that way. And these are the activities for this week, which, as I scroll down now again on the side, we have the real player that you can download. It's a free download if you do it properly. And then these are the various lectures and homeworks that have been done. So if I looked at the most recent, which was yesterday's, all you have to do once it's uploaded is click on that, and this will bring in the real player if it's downloaded, and I'm waiting for it to come up. And this isn't the latest version of the player, but let me move over a little bit. I don't like the way that does it. I'll just increase the size. And that's looking at yesterday's lecture and listening to Aretha Franklin. And if I just come up here to you can see where the cursor is at the top of the page. There's a little linear here that you can change, and just by moving that ahead, now there's an expression for you. But that's into the buffering mode momentarily. And eventually, I quit looking so silly, and we go into the presentation. And you can control the volume. Now this is, for some reason, having trouble selecting at 225 again, and I'm not sure why. We evidently are trying to serve a little bit too much at the moment, because that should be across a network connection coming.
Is there something you could do about the volume from in here? Because when I put the headphones on over there, I have them up as loud as they go, and it still kind of can I hardly...
Well, you can control the volume on the computer you're watching, and this is not... This is coming at about 169, so we're having trouble. I can pause it, but the problem here, we are having, until I think sometime in February, a problem with how many different streams we can run simultaneously. And so this should be coming in at about 225 kilobits per second and shouldn't be running that problem of breaking up and jerky motion and so on. Now, you control the volume on the computer, and then your headphones can control beyond that, but ask for help in a lab and just control the volume on the computer itself. Now, the third lecture, unfortunately, I didn't pick up on it, Ernie didn't pick up on it, and we were doing everything from these microphones. And so the sound quality in the third lecture is very poor. You have to zip it up and you have to listen a little more carefully. The other lectures, the sound volume should be adequate. In fact, I have it overloaded a little bit on yesterday's. The point is, let's come back to the computer now. As we come back to that, and I close that presentation itself down, and it never did get back up beyond 169 kilobits, should have been much higher than that. And this is refreshing very slowly, even off of a network connection. Should be going much faster than that. But the homework assignments are given along with the lecture, and it's your way at the moment of going back and finding out what's happening. I'm going to back out of that, and I'm an IE on this right now, but I'm in Internet Explorer. And if you consider that I'm on a network T1 line right now, you can see we are really being overloaded in some ways because this should be just snapping in much more quickly. I'm going to zoom out just for a moment and back up one more page. Now, this again is the home page for the Math 70. And the simulcast, I am a little bit reluctant to try. But this is supposed to be happening while we speak. The worst that can happen is crash, and why not do it? Yeah, so we'll see what happens. This is supposed to bring up a media player, and I may not have the current version of the media player that it's going to demand on IE. And I'm using a rather archaic system here. We'll see what happens. Let's come off there for a moment while I'm waiting. But this is Windows 95, and I had to resurrect this out of a problem situation yesterday because the new Dell Inspiron does not allow me to connect up with the ScanIt device I'm using, and I have not been able to solve that problem. So I'm punting by going back to a machine I used last semester that had a transformer die on it, and it seems to, by getting some help yesterday, we solved that problem. And we'll see if we indeed are doing simulcast. And this will take just a moment. Well, something's happening on the positive end. There we go. Okay, this is, let's go to the monitor, and that is a 20-second delay, but that's what's happening right now as we speak, and the quality is fair. I think we're going to have to do a better job of doing this. I can't fill the screen on this laptop. I cut off my head, or you can't see what I'm referencing. But that is a presentation of a few seconds ago. So there's that kind of delay. But that's what can be watched this evening at 9 o'clock, and you can watch the broadcast. So if you want a second go at it, you can do that, or you can simply watch the files. And then you can go ahead and watch a VHS tape, which I try to get over by about noon. So those are alternatives, and boy, the quality, let's go to that for a moment, Caesar. At this point, it is not coming across good at all. So what you're seeing is a shot of a shot. That's the screen within the screen. So that's what's being broadcast. Let's come off there again, and enough. Okay, how can I get out of this? Well, I'll just back up. But at least we are doing simulcast at the moment, and things are responding quite slowly up here. There we go. So at any rate, I wanted to share that with you, and one of my hopes, I talked with Clorinda this morning, I'm going to need to have some assistance from her briefly. She's out in Sierra Hall 221. She had been doing all the photos and running the JPEG files. and I just haven't done it recently enough. I'm going to try to sit down with her, get some background in that, and try to have the board presentations with the lectures. I have not had time to do that this week. And this is simply not wanting to close, so the simplest way, we will just close it down. Relative to, well, it doesn't want to stop. Relative to the content of the video tutorials, I'm going to try to work on that this weekend. Basically what I have to do now is run about 4 lectures on a CD, or maybe a couple CDs, take those home so I can work with them, get timing marks, and try to have for you some modest video tutorial started by Monday. So depending on how my weekend goes, that's the hope. Essentially I have to listen to 5 hours of presentation again and run timing marks and then cue those back up on another page and have them in a meaningful way. I don't think I'll get all that done. That means about 10 hours of work, and I'd like a weekend of some nature. I'm going to watch a few games. So that's at least in the offing. Let's leave it at that. And I don't really have a luxury of getting too much further behind in that, or it's not going to happen. I ask you to do the buffet, the algebraic buffet, where you spent some time in homework problems for this week, or this homework that you did for last night. You didn't have anything to turn in today, and I'm trying to shut this down so I have some room to work with here. And pretty soon we're going to have the infamous greeting from Windows, I think, as it shuts down. But do you have questions on the problems you tried, things that you'd like us to talk about? Okay. I'm going to be distracted a little bit. This machine had a transformer problem, and I have bombed it out doing a boot yesterday, and now it's updating a registry, which I'm not real... There, good. It looks like it's going to shut down. So, questions from homework? Anything you did that you wanted to talk about? Well, that's good then. If things are going okay in that, and we are ready to move on into Chapter 2 in a formal sort of way. I said we get the greeting from Bill Gates, and this will shut down momentarily, and I'll have some room up here. Okay, well, not real fast as this shut down. I'd like you to turn to Section 2.1, please, of the text. And the page numbers there are up in the 90s. We're talking about page, I guess it's 90 or 88 and 89 is where it starts. So if you will go to there, 88 and 89, we're talking about linear equations and inequalities in one variable. And that's what we're going to be discussing. Now notice we've gone from the phrase expressions to equations, and with that in mind, as I disconnect some equipment here quickly, we are talking about something characterized by having an equal sign in it. Remember, that's how we distinguish between an equation and an expression. So one of the things I didn't say too much about yesterday, the last couple days, is an inequality. But let's go to this title shot, Linear Equations and Inequalities in One Variable. So I do need to bring something to your attention here. If we talk about an inequality, we're going to use a symbol different than an equation. And so I need to talk about that briefly. The equation that we talked about yesterday was something like this, where we had 2x minus 1, and we wanted that to equal 3. And we said that we could just, by observation, note that if x has a value of 2, it makes that a true statement. And you did some problems in the homework where you verified that you had a solution. So we argue that x equals 2 is the solution to this problem. And it was understood that x was going to be a counting number. If I change the expression on the left, well, the right side, didn't say that well because I'm not actually changing the expression, I'm going to change the equation. but I'm going to change the symbol for equality to a less than. The equation now is an inequality. So we are asking for a solution to this expression now so that 2x minus 1 is less than 3. Now, if I maintain that I want my values for x to be counting numbers, remember the argument here, and I'll just put this at the top. X was going to be a positive integer. That's a nice way of saying a counting number. Then what values will work here? Well, if I put 2 into this problem, I get, on the left side, 3. And 3 is not less than 3, so that's not a solution. So when I had x equals 2 here, the left side gave me a 3. The right side is a 3. 3 is not less than 3, so that value is not a solution. If I put x equals 1, and that's the only other choice I have, then I get 2 times 1 minus 1, which is just 1. 1 is less than 3, so I only have one solution here. X equals 1. If I rewrite this inequality in the following way. Now 2 will work, because when I substitute 2, I get 3, and 3 is less than or equal to 3. So the statement, 3 less than or equal to 3, is a true statement. Now you have to be a little bit cautious in the way you use or when we talk about mathematics. Most of us as kids grew up with statements from parents that went something like this: eat the liver or no dessert. Behave or you're going to your room. And it was sort of a mutually exclusive kind of statement. Now, to say that 3 is less than or equal to 3 allows for two possibilities. Less than 3 makes it a true statement, and equals 3 makes it a true statement. So it's one or the other. We can't have both simultaneously in this case, but it's not excluding one or the other. So x equals 2 is a solution. And because 1 is less than or equal to 3, x equaled 1 was a solution. So now I have two solutions in this problem. We could indicate the solution set as two values, 1 and 2. A set being a collection of numbers. So this distinction between an equation and an inequality is rather important. If I think of these two problems with x in the real numbers. So x in the real numbers now. Then the solutions are going to change considerably. Relative to the equation, I still have one number. So when I look at x in the real numbers and I look at this equation, I still have just x equals 2. Is that comfortable? But now what happens if I look at the inequality, and let's take the case where I have less than or equal to 3. Will 0 work this time? I take 2 times 0, get 0, get minus 1 when I add. Is minus 1 less than or equal to 3? The answer is yes. Now the question is, how do we interpret less than? And one very simple way is to say left of. So less than can be interpreted on a number line as meaning to the left of. So is minus 1 to the left of 3? And the answer is yes. And we would need a number line, perhaps to analyze this a little bit better. And I just realized my straight edges over there. So let me just sketch my effort at a line. Now, what's perhaps implied there, and unfortunately not intended, that I have the middle of the line. the line goes in what? Both directions infinitely far. And so to think of a middle per se is not a reasonable kind of statement. And if I, in some way, put a scale on here, and I'm not doing this as uniformly as I'd like, but it would seem to imply that I have what? Just integers. But the number line represents all possible real numbers. So there's this kind of reversibility. If I have a real number, I can locate it on the number line. If I have a point on the line, I can associate it with a real number. Now, 1 worked here, 0 worked here, would 1/2 work here? If I put 1/2 into this problem, 2 times 1/2 is 1. 1 minus 1 is 0, and 0 is to the left of 3. So I have numbers besides integers that are solutions. What about negative pi? Negative 3.14159 and forever. Well, that's going to be negative 6.28 and more garbage to come. With a negative 1, that's going to be a negative 7 something, and that's to the left of. The number of solutions for this problem are infinite. One solution here, infinitely many solutions here. Now, we talked yesterday about how we could take a statement and using properties of addition, add something to an equality in both sides. The same thing, we still have the same solution. So I'm going to add 1 to both sides. Now, I, for the moment, will allow this because I want to convince you that I am adding the same thing to both sides. To limit yourself to solutions where you have to show this step every time is to make it too tedious, and it's not going to work for you. So at some point we're going to have to say mentally you add the same thing to both sides, and you then get 2x is less than or equal to 4. And then I prefer to multiply both sides by the same number rather than think of division. And I'm going to multiply both sides by 1/2. Again, I could go about this by putting a 1/2 here. I put a 1/2 here, and I'm thinking in terms of multiplication. But if you were to, in this process, every time you do a problem like this, have to think about showing this step, you're just going to put yourself into too much time consumption. The point being, this becomes x less than or equal to 2. Now that is a statement that says anything to the left of 2 or at 2 is a solution. So we oftentimes show the solution set as something with the number line where I circle the 2, I fill in that circle because 2 is included, and then I'm going to what? Do something on the number line that indicates to you my solution set in a visual way. Or, remember I talked about how I could take, and we're going to have to slide just a little bit to the left, Caesar, where I had the set containing 1 and 2. Now set notation can be done, the set of x such that x is less than or equal to 2 can be my solution set. Or I can use parentheses, block on the right, indicating I'm going to include the 2 here, and put minus infinity over here, which means we are going from 2, including 2, and going to the left forever. Those are all valid representations of a solution. And that is notation that I expect you to be able to use and should be part of your vocabulary, your knowledge base, henceforth, assuming that you are taking this course with the idea that you're opening doors to other courses, that notation is critical, that you know it, you understand it, and you not forget it. Okay? Any questions on it? Now, if I had instead of the less than or equal to 3 that you see right here, strict inequality. Now, Caesar, are you in camera 1 or 2? Okay, could you take camera 1 and show me the strict inequality on the left side of the board, where we have 2x minus 1 less than 3. Look at the monitor. 2x minus 1 less than 3 is a strict inequality. Now, how would I show this solution if x is not just an integer, but a real number? So we'll come back to camera 2. And I'm asking if I come back to this same problem, but now say 2x minus 1 less than 3, strict inequality, x is a real number, the solution is going to be x less than 2, not equal to 2. How am I going to change my presentation on the number line?
Don't include the 2.
Okay, I don't fill in the dot.
Right.
I just have an open circle around the dot because I do not have equality. Is that clear? So if I then look at a line, and just for reference point, put a 0 there, and then come over here at 2, I would circle the point at 2. That 2 is not reading very clearly now. So let me see if I can go ahead and make that a little less confusing. So I have my value at 2. I'll go ahead in the greens, that's sort of a mint green, and come this way. And I think you can see, I hope, the distinction between these two now as to when you include the circle and don't. Now, one of the difficulties as you deal with algebra, and I'll reference this more often than you like, I suspect, and that has to do with what you are allowed to forget. And there isn't much. When we cover topics like this, there's no slack. You have to remember it. And you have to come back and make sure you don't lose it. Now, hearing it for 30 seconds and seeing it for maybe a minute and a half or a short discussion does not necessarily burn it into your brain like we burn CDs into memory. Hence, one of the things you may find it necessary is to go back and review a portion of a lecture and hear it again. And that's the advantage you have with the modality that we are using in here, where you can go back and watch lectures. Your recall of what we do has to be nearly total. Now, you can take other courses and you can get by with sloppy memory. You aren't going to pull it off in an algebra course, and I can only afford so much repetition and redundancy in the process. So when I cover something, take a note on it and make sure it stays with you, because collectively as we go on, the little glitches that you forget, the little dropped pieces of information here and there will come back and haunt you in the process. Now, this first section of Chapter 2 involves taking equations and inequalities and simplifying them so that we don't have to just, as an observation, say a certain value we can see that works. Now, I'm going to leave the camera position right where we are, and I'm just going to move over to here. When I had this equation, I did not do a simplification. I expected you to be able to eyeball it and decide that 2 works. And that works pretty well. You had in the homework I returned to you today a variety of problems where you translated from a verbal statement into an algebraic expression, and you were then expected to do what? What was the phrase? Simplify the expression. Simplifying expressions and modifying expressions is most of what we do in this course, in addition to translating from a verbal statement into an algebraic expression or equation. Now, I tried to illustrate that in a more interesting way yesterday looking at a golden rectangle. But when we get into section 2.3, we go into immediately what you probably reference as word problems, where we try to translate from a problem given to an equation or inequality which you then solve. Now, the process is very simplistic as illustrated in what I had right here. A set of steps that you do to ultimately get whatever is on the left down to a single variable with a coefficient of 1. And the argument is that each of these inequalities or equations I generate have the same solution as the original. Now, there is a statement given in your book in section 2.1 of what you were allowed to do. And that is on that page we just had. I'm going to come to the center of the desk here and reference page 89. I'll get to the question in a moment. There are two things I want to talk about. Let's go to the book. The first statement is what we talked about, general form, ax plus b, and we have it then as an equation when we put it equal to 0. Note, if it's a linear equation in one variable, the understanding is that the exponent on x is 1. It is the unseen exponent on the variable. It is a 1. The coefficient is a. A cannot be 0 if we are going to have a variable here. Now, we have an expression coming off there. If you have an equality, and this is the rather critical statement on page 90. If you have an equality, A equals B, A and B equal to each other, the statement is you can add C to both sides. And whatever you had as a solution in the original problem will be a solution in the new problem. This is sometimes referred to as the well-defined property of equality with respect to addition. There is, in a similar way, a well-defined property of equality, as we go to the book, for multiplication, where we think of multiplying both sides by something not equal to 0. Now again, a question of how formal you get in this process. How many steps do you show? As we do this at an introductory level, we probably do it ad nauseum. Much in the same way, when you learn to walk, you do it with great deliberation. At some point, you just start running. In another, perhaps more recent process, learning to drive. When you first get behind the wheel out of McHenry Avenue, first time you've driven, terror is the first thing in your mind, and avoiding hitting somebody or getting a ticket. And it seems like it will never get easy. And then at some point you fly around town without much a thought in the process, and it becomes easy. Algebra is very similar. When we start out the process, the steps are tedious. You wonder if you're doing it right, you lack confidence, you're afraid of crashing in an intellectual sense. And then at some point, it just becomes simple and you hardly think about it, and the moves become very automatic. That's where we're headed. The process in between sometimes gets rather frustrating to get that comfort level. Now the question.
I just was going to ask on this equation over here, when you redid it.
Did you say equation?
Excuse me. Sorry, inequality.
Okay. First, let's get to where we're talking about. We're on the right side of the board with an inequality, and I assume about here. Good.
Yeah, the first one. When
the
you
first
did
one.
Answer, you did negative infinity with parentheses, and then the.
Okay, that was the solution to an inequality that was visible here, which was any value of x on the real number line to the left of 2 or including 2. And I represented it in 3 different formats. Now your question.
And on the bottom one, when you redid it, wouldn't you write it with negative infinity parentheses on both sides?
Ah, you're wanting to know how would I get a similar solution as I've done here.
It's the same answer, but just with parentheses, correct?
Hence, therefore, would not be the same answer.
Oh,
Okay, so let's slide over.
Yeah.
Same concept,
Yeah.
same generalization. So if I come down here, I would have negative infinity, open parentheses, comma, the 2, but now open parentheses, you're correct, because I do not want to include the 2. Good question. So make sure you distinguish between these two expressions. Now, unfortunately, the first reaction many of you may have to something being in parentheses is an ordered pair that we would plot as a point doing a graph. That's not intended here, okay? But does that answer your question? Good. Any other questions on that since that was raised? Okay. I'm going to show you a solution to a problem illustrating the property of equality with respect to multiplication. This is on page 92. And the question, how much of this is necessary? I mean, this is sort of overkill. You're trying to illustrate what you're doing. You had 3x equals 15. First question as we come off there, 3x equals 15 is my equation. Can you see the solution with just observation without doing anything? If you can, then that's reasonable. Now, I'm needing to get something to flatten out what I want here. I knew these tapes were good for something. And let me... Okay, let's go to the document camp. There's 3x equals 15. Now, if I look at that as an equation, I can see that x at 5 solves the equation. Now, the question as I come over to the side, Caesar, is why are we going through so much in solving this? Is it really necessary? And how much of it is just making you do busy work? Well, part of the goal here is to understand the use of the 11 properties of the real number system and verify for yourself that the steps you are doing are valid. And hence, if we look at the document cam, that first step where you're multiplying by 1/3 on both sides is first a property of equality. You can just barely see the next step where the parentheses have been changed. So if I look at what I have up here with the same intent, the left side, you need to understand that to make this work, technically you use the associative property to get the 1/3 and the 3 together. I'm going to leave this alone on the right side for the moment, understanding that that's going to be what? Just a 5. And that's simply a matter of multiplying 1/3 times 15, although you could think of factoring 15 into 3 times 5, do the associative property, and sort of drag it out ad nauseum. But here, the 1/3 times 3 is what? 1 by the inverse property. And then that gives you 1 times x. I'm going to leave the 5 here. I'm just going to make that transition. And now by the identity property, this becomes x. Now that is trying to demonstrate to you that each of these steps is defended by one of the acceptable operations I can do, and those are very well defined. We have 11 properties plus 2 properties of equality. The well-defined property of equality with respect to addition and multiplication. At a practical level, what would I do if I were just doing this problem and I wanted to show for myself what was done to get the solution? I would do not much more than this and done. Now, if I'm doing this realistically from the approach I would have in a test question or something where I need to get the solution quickly, I don't even show that much. I say, gee, I can divide both sides by 3, therefore x equals 5, and I'm done. And I have my solution with a lot of mental work. We have to find some balance in that, okay? So for right now, tend toward, in these early sections, overkill. Force yourself to really understand what you're doing in much the same way you're with the car for the first time on McHenry Avenue and you're trying to make sure you don't do something silly. You'll know quickly enough when we're going to get out of that routine and lighten up, okay? Right now, think of the driving instructor sitting in the seat with you. You signal every lane change. You look in the mirror every time you change lanes. And you drive at the speed limit. Reality is you will defy every one of those constraints very shortly and still survive. So we'll leave that on the side, and I'm going to go back up front. So. If you look at pages 92 and 93, just browse the problems there, I think you can see how much work is created out of a fairly simple problem. So I'm going to try to get this again focused as clearly as I can. Let's look at this one on the document cam. A over 4 equals 3. Can you see that the thing you want to do is multiply both sides by 4 and get A equals 12? Again, you have A over 4 equals 3. You will simply multiply both sides by 4. That will give you A equals 12, and you're done. Look at the steps that are done and the defense that's given as we come off there. So just look at what's done in the book, because that is the understanding. Now we have to make some balance between the mechanics of algebra and the understanding of algebra. And I find it difficult in going through problems like this to make it clear when you see a problem what is intended. So as we go to page 95, let's see at the kinds of things that are discussed here. Now, I'm on exercise 2.1. It asks which pair of equations are equivalent. Now, what do we mean by equivalent? Well, we mean they have the same solution. In essence, if you take 1a and you think of adding -2 to both sides, now that may throw you because you may have been thinking, I'm going to subtract 2 from both sides. Subtracting 2 will give you the same result as adding -2. I would prefer you think in terms of adding a negative. But if you do take 1a and you add -2 to both sides, would you not get x equals 4? So that new equation has the same solution as the original, so we consider them equivalent equations and argue that the second one is a statement of the solution for the first. Okay, small point, but if you don't understand what equivalent means, then you're in trouble. We go through these steps to get, and I'm going to ask Caesar to go back to the sideboard, that first equation. What you see in the monitor, in the television, is a case of getting equivalent equations every step of the way and knowing that each of those has the same solution as the original. Hence, the last one, which says x equals 5, becomes the solution of the first. Now that, in a way, is what algebra is all about. And we just learn the grammar, if you will, the things that we're allowed to do. The equations get more complicated in the process. Now, in some of this, the equations, and I'm going to look at, let's see. Let's try this one, 17. I just want to come down here to 17. There we go. And I have the advantage with the document cam. It makes it really easy to look at an equation. But there's 17. Now, that's a little more cumbersome than what we did on the front board. So, Caesar, let's take the camera 2 and bring that back to an equation that I had on the left side here. So this is the case where we had this equation. We'll just pick that up. Now, that equation and now to the document cam are very similar. Number 17 and what I have up on the board again. What makes them a little more complicated? The fractions. You need to understand what's giving you a headache. Okay? So we're going to have some fractions or decimals, and problems are going to look harder, but fundamentally, ask yourself what you do in a simpler version with just nice numbers. Now, I don't mean to imply that fractions aren't nice, but I think most of you view a fraction with more hostility than you do a counting number. So as we look at 17 again, what will be our guideline here? Well, typically collect the variables on the left side of the equation, the numerical part on the right. So there are two steps here. you can add 1/2 x to both sides and add -2 to both sides. So the problem, and I'll be going to the side again, Caesar, and we'll leave that on the document cam. The problem is going to be how to do that efficiently. So I have 1/2 x plus 2. I needed a moment longer, thank you, plus 2 equals -1/2 x. Now back to the sideboard. I have something wrong. I doubled up. 1/2 x plus 2. There we go. Now I believe it's what we had on the document cam. I want to get the variables on the left-hand side, the terms. Now terms, be careful here. Terms are things you add, unless you're in politics. Terms are things you add. Factors are things you multiply. So a coefficient is a factor. I would like to get this term on the right side to the left side. So I will add 1/2 x to both sides. So if I add 1/2 x to both sides, and this bugs the devil out of me to show this from a personal point of view, because I expect for myself to do that in my head, but you then are going to get 1/2 x plus 1/2 x, and I hope you just feel a obsession, nearly, a obsessive kind of process. Add them and get x. True? 1/2 x and 1/2 x will give you x. 1 times x. But you still have the 2 here, and now you have the 0 on the right side. Now, this becomes, using a distributive property, just x, and I have plus 2 equals 0, and then, of course, it's pretty obvious x should be what? -2 if you're going to have a solution. But if you want to get it in the isolate the x term on the left side, I'm going to add -2 to both sides. And in doing that, I get x plus 0 is equal to -2, and x, therefore, is -2. I mean, we're straining at a gnat here. And we're making something that should be a little bit easier a whole lot more complicated than it seems. But again, find a balance. Now, what are the directions on the problem? Let's go back to the document cam. Somewhere above that problem there's a direction, isn't there? What does it say?
Solve each equation using addition property.
Okay, using an addition problem or property. Let's see where the phrase. Okay, an addition property of equality. So what's intended? As we show the sideboard. Pretty much what I did there. Now, do you have to show the... I guess you do. I'm trying to think, do we have to really show the x plus 0? But yeah, that's what you have on the left side. So unfortunately, that's what's intended. And as much as it's going to drive you nuts, and it's going to make more work than you'd like, show the steps to that extent. I don't expect you to have to show or say or write by the identity property x plus 0 is x, but at least show that you get x plus 0 equal -2. Part of our effort here is to understand the requirement that we identify what we have as a linear equation. And let's see if I can get that. Boy, there are times when this just doesn't look as clean as I'd like. Okay, let's try this. Not bad. You have some equations here. This is problem 21. I'm still on page 95. Now, what is our definition for a linear equation? It says define a linear equation in one variable. How would you define it in words? And if you can't define it in words, then you're in trouble.
Two algebraic expressions that are equal.
Okay, by having an equation, it must be two algebraic expressions that have an equal sign between them, but that's not going to be enough. What must it be in order to have a linear equation in one variable? What's the exponent you have to have on x? A 1. Now, if you don't see the exponent on x, it's still there. The unseen 1. Let's look again at the problem I have on the document, Cam. We have x squared in part A, minus 5x to the first understood. Is it linear? No. It's second degree because I have a 2 on the x in the first term. Now, if you understand the language I used when I said first term, you knew I was there, where I'm pointing. And I said I had an exponent of 2 on the first term. Here was my second term. It was the linear term because the 1 was understood as the exponent with the x. Let's go to part C. That is linear because it has what? Just x to the understood first power. Now, I'm going to consider a little different version here. Let's say the 0 was a y. Would it be a linear equation in one variable? If I had 3x minus 4 equal y. Is it a linear equation in one variable? No.
No, because you have x and y. That's
X
two
and y are
variables.
both variables.
Right.
It's linear. If you were keying on linear, yeah, it's linear. 1 is the exponent for both x and y. But how many variables? 2 because I had x and y. See the difference? Now, come back to the problem. I'm arguing if this 0 were a y, then I'd have 2 variables, linear. And we're going to spend a whole chapter on those. Okay? But for the moment, we are just on one variable. Okay, continuing, as we look at a whole lot more problems, they get more fascinating. Now, the directions, the infamous 2 words now that are part of your vocabulary. I'm on page 96. This is probably the second most often phrase you will see in this course. Solve the equation. The other, simplify the expression. And here, you get to see them together. Solve, but first simplify. Get the idea? Now that first one, I think I just have it all on the screen there. 5t plus 3 plus 2t minus 6t plus 4, equals 4 plus 12. Question, do you ever get equations like that? Or is this the author's effort to cause you a headache? In some ways, as we come back and look at the problem, it's an effort to give you a headache. White, I love the way that drifts on it, at least the monitor I'm looking at back here. Did that change its intensity at all as you looked at it? No, okay. I'm looking at a monitor in the back of the room, and it gets flaky as heck at times. At any rate, why did we use t here instead of x? Good answer. Jill says, just for the heck of it. And that is a good answer, because we'd like you to realize that you can use what? Another letter besides x. So we'll use t, y, x, r. What others are used here? Q, p. Do we use a? Not a or b, typically. Why? That is understood to be a coefficient. Does he give one within there?
35. 35, it's a B in there. Look at 45.
Well, 35. Okay, so bad writing. I know Margaret Lyle. I'll just say this much. I would disagree with her here. I understand what she's trying to do, but it's confusing because what do we usually want to argue? That the letters A and B and C will be coefficients. So that 35th problem, bad choice. But going on the basis of, have you ever written problems for a book? You probably haven't. I've written a number of books. And writing problems is one of the last things I enjoy doing. So you get a good bottle of wine, and you sit down in the evening and say, okay, this is at least going to be enjoyable. Now, it depends how high the contents of the bottle are as to how good the problems are sometimes. And there are times that you just lose sight of what you're trying to do. And this is, I think, a case. Yes, question?
I just want to know why they use the T, because it gets confusing with the plus sign.
Yes, a good argument. Yeah. T's and plus signs, bad choice.
Especially when
Just be forgiving. The sangria was getting close to the bottle.
Should we use a parenthesis in that case, or will it just change the whole face of
I'd say use of a parentheses to clarify, change the variable, get out of the trouble. But let's see something a little more interesting here. Number 40 intrigued me. Now, z's, you can argue, oh boy, just a minute, look too much like 2's, and that still doesn't look good, Caesar. I don't know what I've done wrong there. Let me flatten out the book, change the contrast, and try to get this. Geez, now the whole thing's not working at all. There, shake. I'm going to grumble here in a moment. Now I've lost the problem. There it is. I need to raise it if I don't lose. There we go. That still sucks. Okay, let's see what we've got. It's number 40 I'm trying to look at, and I'm hoping that people who are at home can read that. That's too dark? Tell me when it's good. About there? Well, anyway, what do you have here? You have a mess. Okay, I want to look at this one on the sideboard, so you're going to have to help me. So come off there. That just didn't work at all. There are days when things just don't work. Somebody's going to have to read to me in a verbal form what I'd like to write on the board, and this is where I'll finish things. Okay, Pamela.
Oh, boy.
Read to me what was there. Number 40.
-5.
-5 times.
Times the sum of 1, or I'm sorry, the difference of 1, okay, 1 minus 2z.
But notice, that wasn't so easy. Do you just say 1 minus 2z, or do you say the difference of 1 and 2z?
Yeah.
Okay, I know that's not all. Continue.
Plus 4 times 3 minus z.
You mean the quantity in parentheses?
No, the difference. 4 times
The difference of?
3 minus z, or
Okay.
2z, equals 7 times the sum of 3 and z, 3 plus z.
But isn't that harder to do?
Yes. Yes.
Now, when I have to answer questions on phone messages and try to articulate that way, it's much harder. Now, what can I do in 20 seconds? -5 plus 10z plus 12 minus 4z equals 21 plus 7z. Notice I'm using the little marks through the z's and the 7's. Now, on the left side, I have -5 and 12. That's 7. 10 and -4, that's positive. 6z, I have 21 plus 7z. Then I'm going to add -7 to both sides, add -21 to both sides, add -7z to both sides, and I believe I get -z is equal to, and I just lost it, 14. Therefore, z is equal to 14, -14. Now, that's what I do in practice. You're going to have more fun with that as you show some intermediate steps. Homework is the usual. We are going to do from 1 through, let's see, how about 1 through 80 odd? So 1 through 80 odd. So that's going to be your homework, and that's set 2, 1, and Caesar, I'm out of time. We are listening to whom and what selection? Fleetwood Mac, and your choice as we close? Don't Stop. Oh, I love that. Have a great weekend.